Hi class, today we're talking about exponents and I'm on notes 5-1 and I'm on page 2 in your binder. So, an exponent tells you the number of times the base is used as a factor. So, a factor, all it's saying is just the number of times a number is multiplied together. So, in the example, if we look at this here, the 4 is the base. The big number is going to be the base. So you can think of it as the big base. The 3 is the exponent. So the little number is the exponent, the little one up to the power of. And when we write this out, 4 to the third, we are multiplying out the base, which is 4. We're multiplying it out 3 times. So it's really 4 times 4 times 4, or 64. You can use your calculator to solve this. So if you type into your calculator 4, and then you hit the exponent button, which is the y to the x button, it's right above the division symbol. It looks like this. So it's a little button that looks like that. It's right above the division symbol on your calculator. And if you hit 4 and then you hit the YX button and then you type 3 and then make sure you hit equals, you'll get 64 out of your calculator. Now there's two different forms, and you can see from little brackets here. This form right here is exponential form. So it's written with an exponent, so that's why it's called exponential form. Now there's two different ways you can say this form here, where it's all written out, the 4 3 times. You can either call this factor form, you can call it product form. And actually there is one more name for it that we can write. We can call it expanded form. So there's actually 3 different names for it. So we have factor form, product form, and expanded form. When it's all written out, expanded like this. When it has the little exponent, it's exponential form. So it says, remember, any number to the 0 power. If you type in, let's say, 3 to the 0 in your calculator, so if you type 3 and then you hit the YX button, this little button here above the division symbol, and then you type in 0 and hit equals at the end, you're actually always going to get 1. So anything to the 0 power is always going to be 1, and that's something really good for you to memorize, that anything to the 0 power is 1. Except for 0. If you do 0 to the 0 power, you actually end up with 0. So that's the only exception to that one. But anything else to the 0 power is 1. Alright, so let's look at our examples down below. So in this first example, we have 9 cubed. What does cubed mean? It's to a power, because we're going to make an exponent. Think of a cube when you see it, see the shape of cube. Is the shape flat, so is it 2D? Or does the shape pop out at you, so it's 3D? If you think of a cube, it actually pops out at you, so it's 3D. So we're actually going to have an exponent of 3. So it's 6 to the 3rd power. If we write this in expanded form, we're going to write it out 6 times 6 times 6. And you can either multiply 6 times 6 times 6, or you can do 6 to the 3rd power. If you do 6 to the 3rd power, that's 6, and then you hit the y to the x button, and then type 3, and hit equals, you'll get 216. Okay, let's look at the next one. So if we look at the next one, we're given the expanded form, and we don't have the product or the exponent. So if we look at this, the base, which means the numbers being multiplied together, is 4. So the big number is 4. And the exponent is how many times it's multiplied together. So we're actually multiplying it together 1, 2, 3, 4, 5, 6, 7 times. So the exponent is 7. Now you could multiply this out 4 times 4 times 4 times 4 times 4 times 4 times 4. Or you could type in your calculator 4, hit the YX button, then type 7, and hit equals, and you will get 16,384. Okay? Let's look at the ones down below. So I want you to take the opportunity right now, pause the video, see if you can figure out how to solve 3, 4, 5, 6, 7, and 8. Careful with number 7. Think about, what does squared mean? Is a square flat, or is it 3D and pop out at you? If it's flat, it's called 2D. So think about what that means. So pause the video here. Do those. Whenever you're ready, unpause the video. Alright, here are your answers to your question that you were to solve. Be careful with number 3. It was to the first power, so your product form only has 163 here. Also be careful with number 7, where it says 15 squared. A square is flat, so it's called 2D. So the exponent is 2, and that's just going to be 15 multiplied together 2 times. Let's look at the next page. So we're talking about numbers called perfect squares on this page. And a perfect square is a number that can be expressed as a product of two equal integers. So when we're talking a perfect square, we're talking about a number to the exponent of 2. So if we were to write this out in product form or in factor form, because we're using the word factor here, I would write this out 0 times 0, which is going to give me 0. Now in that case, 0 isn't really a good example of what we're doing because it's not really showing a picture because it's 0. But if we look at the next example, 1 to the second power, we can write that out as 1 times 1. And if we use our graph paper on page 4, we can draw a box that is 1 box high and 1 box across, and we can color that in. And how many squares make up that box? Well, 1 square makes up that box. So the perfect square of 1 is 1. And we can do the same thing for 2 squared. It's going to be 2 times 2. And if we were to draw it, I'm going to use a highlighter this time. Oh, maybe highlighter gets a little funny. 2 by 2, so it's 2 boxes down and 2 boxes across. Think of it like a multiplication chart. And if I color that in, how many boxes make up that square? Well, there's 4 boxes that make up that square. So the perfect square of 2 is 4. Let's do the same thing with 3. So we have 3 squared, so it's going to be written out 3 times 3. And I can draw it. It's going to be 3 down and 3 across, 3 by 3. And I can color my boxes. And if I count up all the boxes, 1, 2, 3, 4, 5, 6, 7, 8, 9. So the perfect square of 3 is 9. Now, what happens when we have, say, the perfect square of 7? Well, if we were to color 7 squares, 1, 2, 3, 4, 5, 6, 7. You have to think to yourself, does that make a perfect square? Is 7 a perfect square? And if you look at that, that doesn't really make a square. It makes kind of like a rectangle with an extra piece on the end. So in this case, 7 is not a perfect square. You could also think to yourself, there's not something times itself. Like here we had 1 times 1, 2 times 2, 3 times 3. there's not something times itself that equals 7. So 7's not a perfect square. Alright, so I want you to try from 4 to the second the whole way down to 12 to the second. If you need to use the graph paper like we did at the bottom of page 4 down here, you can do that. But I want you to try to use your calculator or use your brain. These are basic facts, so you should be able to do it without using your calculator. Whenever you're ready, unpause the video and you can check your work. Alright, here are your answers so that you can check your work. If you need to pause the video, go ahead, pause the video so that you can check them. Once you check your work, I want you to complete page 5. Once you've completed page 5, please raise your hand and I'll check your work, and then you can go on to the activity.